let me ask, and maybe show of hands in the rooms, who's a developer or manages development teams? Any developers in the room? Few hands. Others are kind of infrastructure, cloud ops. That's what we got. Okay, awesome, great. So hopefully we'll have some good news for all of you. Standard disclaimer for everyone here. For the developers in the room, and you can shout it out, how much time are you actually spending writing code and developing applications and business value on an average day? 34%? 30 or 40%. Okay. That's, I think, pretty good. Anyone else? More than that? Less than that? Wow. Okay. Well, according to a study done by InfoWorld and IDC, you guys are doing really, really well. Hundreds of developers and professionals in 2024 were surveyed, and the stats came back 16% is the average amount of time that developers are actually writing code, up 1% from 2023. So there's many other things that developers are doing, like documentation, operations, security, meetings, other things, right? And developers are usually pretty highly paid resources. There's a lot of cost, and I think what they're developing is custom applications are either meant to make the company money or save the company money. So it's a huge focus for us at Broadcom, specifically within the Tanzu division, and I'm part of the Tanzu division and our go-to-market team, to help developers spend more time writing code. And a big thing that we believe can do that is AI. Gen AI, Agentic AI, Spring AI. So AI is the buzzword for everywhere, right? But Spring AI and Tanzu and VMware and Broadcom are the stewards of Spring. We'll talk more about that later. We feel that leveraging Spring AI in your development lifecycle can create automation, can increase security, and give developers more time to actually write code. It would be great if all developers were spending 30 to 40 to 50%, but I don't think that is the standard. And what we're going to do is we're going to talk about how we can do that. You're going to see a really awesome demo. And to talk about that cool stuff in that demo, I want to introduce a good friend of mine, Banu, who is a field CTO for a major financial services customer at one of our top Tanzu partners, Emphasis. He's been a developer for decades, and he actually even wrote a book about mastering Spring AI. So for all the cool stuff, I'm going to let the guy who wrote the book lead that next part of the conversation in the demo.
Thank you, Andrew. So before I start, what I would like to understand from you folks is how many of you have used Copilot today? Nice. And what else? How many have used agents or deployed MCP service or used MCP service within? Nice. So what I'm going to be talking today is about, one is the problem that is ahead of us, right, when it comes to MCP and agents and when it comes to actually software development lifecycle. So what I'm talking about here is basically, I mean, you have Copilot, it's great, right? We need to move on from AI being a Copilot to being the center, to being the fabric of our software development lifecycle, like a central nervous system that connects requirements, architecture, delivery pipelines, including infrastructure, observability into infrastructure. As we are, as different teams operate on this SDLC, all of them need to have that visibility, right? And today, this visibility is happening. Let me just. So, what does it mean to be more than Copilot, right? So, current focus is too narrow, right? So, what is it? We're talking about, writing code, having the AI generate code for us, and possibly we then deploy the code, right, to us. What do you call it? We code commit to GitHub, and from there we kick off GitHub Actions, and it goes and basically deploys to the right containers or servers, right? That is how the process is today. But feedback on the deployment is not there yet. I mean, you can't go to Copilot and say how my deployments are happening. I mean, what is the status of my deployment? You have to connect to something to get that information, right? And then you keep adding MCP servers. I want to look at how my servers are doing. I want to look at how my Jira is doing, how my requirements are doing. Are there any requirement gaps that I need to meet? And if you keep on adding MCP servers to all the tools within your organization, it'll be overwhelming for even Copilot to handle it, even though Copilot handles MCP, right, today. So connecting the dot is very important, right, for any software development lifecycle, right? I need to be, as a project manager, I need to know whether my project is going to succeed, whether my sprint is going, how's my sprint going, et cetera, et cetera, et cetera. And creating this traceable system is the key to success, right, in the future, especially with the way that the AI has engulfed the software development lifecycle. Today, we should make use of the right components in order to get this, moving faster. So just a note here, that Copilot is just not enough. We need to think beyond it when it comes to software development lifecycle. So, moving on to the next one, the vision is an autonomous engine for software creation. I'm not specifying software product development, but software creation. It's the whole process of actually product development. Now, what I'm talking about here is basically a single AI augmented platform where your requirements are validated, tasks are auto-generated, ADRs, for example, are contextual, and dashboards tell you what's wrong but not a fix. This is something we feel that, from the core capabilities, what are the core capabilities that we need to enable, right? Shared context and memory. You need to be able to understand every detail of the requirements and how it is being coded and deployed. You need to have agentic automation behind the scenes, right? You need to have workflows that are going through like, for example, the deployment or basically testing workflows, for example, right? Traceability graph. You have to know from requirements to the deployment, you need to be able to trace how it's going, right? You need to understand how to basically connect each requirement to a deployment, for example, or basically monitor the end state. So that is important. Lifecycle validation is another, basically to understand, if a particular code has passed a gate, like a testing gate or a quality gate, etc. And decision capture, whatever decisions you make, you need to be able to capture. And that is your ADRs, right? The architectural decision records. So whenever you make a decision, today in in Copilot, when you enter a prompt, are you, for example, capturing that prompt so that you can then that is your decision that you make, right, in a development lifecycle. So the prompt that goes into Copilot today, are you capturing that prompt, right? So we need to be able to capture that prompt as an ADR. Why did we make a decision? Why did we tell Copilot to do this, right? So that's your ADR for that. And governance and compliance, and of course, auditing. You need to be able to audit your code, your deployments, your entire life cycle, for example, right? So that is the vision. It's basically creating an autonomous engine, right? And today, this is the architecture behind this autonomous engine. And what we call it is an enterprise AI engineering platform architecture. So it's too many words of engineering, but yes, this is what we call an AI fabric. We have this kind of trademark. This is something new. And what I'm going to show you is just a beta, a pre-beta version of the product that we are, or a framework that we are building. And what this architecture is composed of, one is a unified experience layer. So today, all your designs, like whether you use Figma, whether you use, Backstage for, your IDP, as an IDP, all of that, or VS Code, that acts, that you need an experience layer that basically connects your MCP service, right? You just cannot say, okay, I got my MCP servers, I'm good, and I can just connect to them. Now imagine in an enterprise, at the most, you'll be deploying at least 1,000 MCP servers. And each of these MCP servers, at least for a minimum, will have 50 tools in them. Imagine providing this entire list of MCP servers right up to the LLM or Copilot. Your context window is gone, right? So what do you do, right? So that is where we come in and say, hey, there is something we handle through something called an AI fabric, which allows you to basically, that includes the registry, wherein you have the metadata of each of these MCP servers, and also be able to lazy load, for example, 10 tools per time or 50 tools, depending upon how you configure. And what will happen is that will give the right context to the LLM at that point. And therefore, you will be able to get the right code out and the right outcomes for your projects. So that is what the unified experience layer and intelligent fabric will provide, plus a zero trust gateway. Of course, there is a gateway for all these MCP servers, and zero trust is something where we have both IDP and identity management taken care of, plus your security around who can access and what can be done at each MCP layer, each call that you make to the MCP, right? Now imagine if you have autonomous agents. I will talk about it. Imagine if you have autonomous agents. How do you manage those autonomous agents when they talk to MCP servers? How do you make sure that they have the right privileges to access the right MCP server at that point in time, right? Those are all the constructs behind the zero trust gateway that we're building. And finally, the foundational tool chain, of course, everything related to running your CI/CD process to basically, artifact management, like for example, connecting to JFrog, and finally observability. Observability is key, right? You write code, you deploy, and your agents are doing it, right? Or some other AI is doing it for you, right? You need to be able to observe at every point in time. So that's the whole. Both the fabric as well as the platform constitutes what we're calling it as an AI engineering platform. And that is something that I'll show you a glimpse of it as in the demo. And then before we do that, this is how it looks like, right? Now, there are two different kinds of interfaces. One is for a developer and one is for the entire team. Today, teams use, either Microsoft Teams or Slack, right, for conversations, right? But then they go off and look at Jira tickets or look at whatever, or Monday.com to basically manage their Kanban or Scrum or whatever they are doing with their projects. There are multiple interfaces. So the idea behind the whole, what you will see in the demo is basically you just use one particular tool for your team. The developers can use a chat interface like for example OpenCode or Copilot or Cursor or whatever tool they like. But in the end, they'll be interacting with the other team members through a Slack-like interface. Here we call the SDLC chat ops. And through the chat ops, you'll be able to ask your questions about, you can actually, if you want, you can write code within your chat ops. And that is that's the flexibility we give you. And what you can do with this, you can, for example, estimate the timeline for your project. You can estimate, what the cost of the project. You can estimate your burn rate. You can estimate how your project's doing at any point in time, right? Those are some of the things. You ask the questions in the meeting. You can have it as a group meeting, and you can ask these questions, and then have AI assist you as a group member, right? Today, that capability I think is missing. But correct me if I'm wrong. But today, what is just a conversation. If you look at it, if you go to Slack, there's an AI bot and it helps you with analyzing your entire conversation. But that's not it, right? What we are trying to do is basically have the AI assistant act as an agent within the meeting to basically provide suggestions. So you can keep talking, and all you say, okay, AI agent, please intervene, and continues talking. So that is an example of an SDLC chat ops. So this is our structure. So basically, you have a chat interface, either for using open code or using a Slack-like interface. And then you have the client and orchestration layer. That is the key layer. And then which connects, and you have GenAI for Tanzu. That is critical, right? So Tanzu has a great platform for support. And if you had looked at what Tanzu has developed, is an ability to basically use models and deploy models within Tanzu. That's the GenAI for Tanzu. And within that, you can then connect your MCP service through Tanzu, and that basically is simply put, that is what the entire framework is. And behind the chat interface, that is where we call the AI fabric lies, and the fabric consists of everything that you're seeing here. And how many of you are using, just a quick question, how many of you are using public AIs, like for example, ChatGPT for coding? When you're coding in Copilot, are you connecting outside of your organization and sending code? Is that the norm? Right? So
a little bit of both.
Right?
Some yes, some no, I see.
Okay. So basically, I work for a financial services company, right? And if you look at the security and the guidelines provided by this financial services company, you cannot basically send your code out or send anything out, right? It becomes a problem, right? You have to go through all the regulations to basically. So what my suggestion is, if you are in those kinds of environments where you need to have your conform to these guidelines, then the best way is to use GenAI from Tanzu and deploy a local model, right? Like for example, Qwen, or even GPT OSS. That's the latest one that has been released, or anything that can run with and that can be served within, locally within the four walls of your enterprise. So that is what the Tanzu platform will provide you, and please make use of it. I mean, that's what most of the financial services are doing today. And I just had a discussion with one of our customers, and they are adamant that they don't want any of the prompts to go outside. All right, they want to deploy everything and be within the data centers, and have the people not go have their developers or any of the team members not go through go outside, right, and use any of the public APIs or public AI GenAI platforms. So that is something you may have to look at. And again, I'm saying a local LLM gives you the right amount of output. You don't have to rely on reasoning agents like GPT. You have good agents, coding agents like Qwen Coder. You got Llama Coder, etc. Within that can be deployed locally. So finally, let's go to the demo for a minute. And in the demo, what I've done is all of this is using a local LLM. Okay, and let me just give it. Does it change? Yeah, window wrap. Choose window wrap, mirror. So what you see here is I've already prompted, and this takes time for generating. So I'll show you what happens when you prompt, and I'll show you some of the screens when MCP servers are called. So basically a simple SDLC manager like this, right? you have personas, and each of these personas have got channels, and you've got different prompts associated that you can leverage. And for example, a developer can, ask about code reviews. You can ask about tech data analysis. You can talk about, I want to generate API documentation. From here itself, you can do it, right? Like for example, I can generate ADRs from here. I can have the Gen AI look at a particular requirement, and I just say prompt, take a look at this requirement and create me an ADR, or create me a user story. All of this can be done within this interface, and all of this, including system monitoring. What else? Architecture deployment, and then for example, I've just taken an example of, since I'm running Docker here, I've also got Cloud Foundry connections. So I created an MCP server for Cloud Foundry, and also for Kubernetes and Docker that is running. And basically, you can ask any of these questions, like, give me the status of my Docker. You can ask that, and all of this you can basically look at. For example, here, this one is list ADRs. Now you can deploy these. You can create and push these ADRs to GitHub and Jira, and this gets recorded here. And this is some of the lists. Like for example, what's the Docker status? It goes to the MCP server and get me the result. There's still some work to be done on rendering, but yes, this is what it is. I can list all my requirements in Jira, get a summarization of what my requirements and what I need to do, for example, what are the next steps for a thing. So all of this can be then added onto a meeting, and basically you can discuss it in your meeting too. So you have, for example, what are the status of my builds? You get the build status from GitHub Actions. You can look at what are the recent failures, for example. You can look at your, traceability is another thing. So we have an MCP server that allows you to trace with using Neo4j. It has a hook to Neo4j, so you can actually trace all your requirements using Neo4j. That's something, and you can bring it back and basically ask questions about that. And what else is interesting? Again, is status of Cloud Foundry. And then, for example, Docker storage. You can have it analyze your local environments. You can analyze your external environments and give you some feedback on it. Another thing which is also interesting is the ability to have a conversation and then infuse AI when necessary, right? For example, here you can just add, like for example, this is what your sprint planning is, and you're currently, going through the sprint planning process, and the project manager will ask for a meeting agenda. And you can pick and choose what, for example, here you can pick and choose what meeting agenda you want to discuss. Now you can bring in another person here and start discussion, or then, for example, ask AI to basically do it. And this is an example of an output. So this will it'll take a look at all your requirements and then give you a synopsis of what is happening and what are the suggested actions, what it observes. So all of this is being done and using a chat interface, and then you can go back to your chat, right? So all of this is done in a manner that you're not losing the context of your chat, of your conversations that are happening either in Slack or Meeting or Teams, for example, or whatever tool that you're using for Teams. So that is, in a sense, what it is. I can just show you some of the servers.
And Bonu, this is built and powered with Spring AI.
Yeah, exactly. All of that you see here today is all done through Spring AI. And it is so easy to set up as MCP server Spring AI, right? It's just 2 lines or 3 lines of code. And creating a client out of it is also simple. So if you're Spring AI experts, I think this whole process is quite easy to accomplish. Any questions on this before I move on to my decks? You want to?
So with all the MCP servers that you've got, you start talking about protection there. And I know Avi's starting to work on some of the protection for MCP servers. Are you working with Avi to integrate in there for some of that security?
So as Tanzu releases its security layer, if you will, this will be incorporated. Today, it's still not there yet. So as and when it comes up, we'll incorporate that.
So from a Tanzu perspective, Tanzu platform is being built, and Spring AI, all of our development can run anywhere. It can run on any cloud. It can run with any language, but we are working with the core teams, with the VCF teams, with the Avi teams to figure out what their roadmap is, how we make the best experience for modern applications and Gen AI applications run on Tanzu platform and leverage the VCF stack. So would love to maybe get afterwards like some more detail. And we've actually got Bert in the room who leads product management for all of our Tanzu products. So Bert's here, and we can talk with him after about specific questions. But yeah.
Cool. One last thing which I want to do. Anybody else has any questions so far? One last thing I want to show you is an orchestrator worker pattern. It is different from, and I'll talk about that. It's different from agentic patterns. And that would be more risk averse for companies that are risk averse to employ that instead of agents. Okay. So what I'm just going to show you is one of the, if I click on one specific thing, I will show you in the background how the orchestrator works. So here you have this orchestrator controller creating, I'm sorry. Are you seeing it? Oh, okay. Sorry. Close, no, I have to show. Mirror.
Oh, you're trying to mirror.
Yeah. Wait, not stop. Add window. Entire screen. Start mirroring. So that is what. So what,
there you go.
So the orchestrator worker pattern is what you will be seeing here. And you will be, I'm not sure if I can show you that. No. So we will talk about that. Okay, there's something is going on there. But yeah, we'll talk about in our slide deck in terms of what type of patterns we can apply. Let me go back to the slide deck. Show. Okay. Now, coming back to the slide, so there are two ways to accomplish this. And one of the ways is, if you are the primary driver is basically you want to avoid any risky operations, you can go with orchestrator worker pattern. And this, of course, these patterns have been published by Anthropic. So you can read about Anthropic and it's, the guide that it had put out and for model context protocol. So orchestrator worker pattern provides that, and you have the autonomous agents. Basically, if you want to just, just give everything to an agent and make it do without any boundaries. Of course, that's another, but it's in high risk. And some of the companies are actually implementing autonomous agents. Because there was no concept of orchestrator worker pattern, before autonomous agents, and the only way to accomplish that was to have a workflow engine behind. But this pattern is available to you with an MCP and a backing, if you will. And this is how the orchestrator worker pattern, works in terms of it shoots out multiple LLM calls and like agents or workers, and then synthesizes the output. Same thing with autonomous agents, but the time taken, running an autonomous agent to get you an output will be much more than when you use an orchestrator worker pattern. And so this is some of the aspects like, the control model, the task, the predictability, cost model, etc. These are some of the, advantages of using one or other. And this is some guidelines we have provided you. Another set is, again, guidance on how you would use, identity management. So that these are some of the patterns. And there are many other patterns, and they apply to agentic world too. And for the orchestrator, these are some of the patterns that you would leverage. And what else? And this is the flow of how you would basically user authenticates and orchestrator receives delegated token, and then the worker A gets to start working, and then orchestrator generates limited time token for the worker A to finish his job, and with a very narrow window of access, if you will. And then that's basically scoping. And then once the worker finishes, then it times out, and then all the information comes back to the control, and orchestrator controls everything. So this is like pattern one is centralized identity proxy, delegated identity chain is the second one, and the role-based worker identity. These are some of the patterns that you can apply for your orchestrator worker pattern. And then guidance on persona-based interactions. I just provided you some prompts and how you would interact with the system to get the right answer. And now I'll give it back to Andrew. Please, go ahead.
Thanks, Banu. That's a great demo and appreciate it. And I just want to kind of wrap up with a couple more highlights and reiterate the technology that is underpinning some of this demo and driving some of the outcomes that we're working with our customers and partners in Tanzu and Spring. Spring and Java, are really kind of the most prevalent developer language in the enterprise. 72% of Java developers use Spring. And again, some people don't know that Broadcom and VMware and Tanzu are the stewards of Spring, the contributors to Spring, that have cultivated a really great open source community, and that we add additional features and functionality and support and know-how when you buy the enterprise version of Spring from Tanzu. Banu mentioned MCP, Model Context Protocol, which many of you were familiar with, right? We built and helped maintain the official Java SDK for MCP. Late last year, Anthropic launched MCP, and very shortly thereafter, we worked, our teams, Bert's team, with Anthropic to launch the Java SDK for MCP, and it was quickly adopted by many of the major players, as you see here. And Banu talked about different industries having different rules and regulations. We want customers to leverage any LLM and models that their organization approves. And it's something that we're going to continue to invest in and help make developing and leveraging Gen AI easier for our customers. And in order to take advantage of some of these AI benefits, you need to be on the latest versions of Spring, Spring Boot, Java. So with the MCP server, you can really integrate that with a really cool tool called Application Advisor to, in a kind of chat prompt way, figure out what versions of Java are not up to date, and then have the tools fix them, upgrade them on your behalf automatically. And we've seen really great results with our customers who leverage the Spring Application Advisor, can actually cut upgrade times in half. And it's a really great tool. It analyzes all of the different code, and it does this continuously over time. And so it's something, if you're not familiar with Application Advisor, we would definitely love to talk to you about it. We would definitely love to figure out how you can leverage it and how it can be integrated with MCP. When you think about technology, right? I used to have a boss who said, there's a lot of technology to create the illusion of simplicity. The models you use are only as good as how hard they've been tested. And we want to reiterate that Spring has been around for over 2 decades. Again, many people use it. We want to make sure you're leveraging all the newest features and functionality. And Tanzu platform, which is built on the Cloud Foundry Elastic Runtime, has been around for almost 15 years, has millions of applications that are in production across some of the largest and most innovative customers out there today. And then there's all these built-in services with Spring, and that can be enhanced and run best on the Tanzu platform. So there's a ton of Spring sessions today. You got a bunch of Spring advocates like Josh Long and Deshaun Carter. So we'd love to talk to you guys about, what's driving you, what questions you have, what challenges you have. And then we're here as an organization with Broadcom, VMware, and Tanzu specifically to provide these awesome tools for you. And we have really great partnerships and emphasis. I just want to highlight that they've been working back to the pivotal days around Tanzu platform, Spring, and they've helped implement our solutions with huge customers. And Banu does that on a daily basis with one of our largest financial customers, but they've done this across different industries, retail, manufacturing, government, certainly finance. And if you've got developers, you're creating custom code, we'd love to be able to work with you on how to drive more business value. So who's ready? Who wants to get into Gen AI with Spring AI? Any questions?
Thank you.
I have a question for Banu.
Yep.
You talked about two approaches, the orchestrator worker approach and then the autonomous
Agent.
agent approach. Would you say the orchestrator worker is the old way to do it and autonomous agent is the new way? How should I think about it?
Agentic approach is an older way of doing it. Well, the older way, because what people had in mind is, I just build agents and I can just deploy them, right? But then when Anthropic said, okay, let's hold back on that particular thought. Not everybody can do that, right? We need to be able to control the agents, right? We cannot send those agents off doing the work for us and we don't have any visibility on what they're doing. So that is where this new pattern has come in, that's an orchestrator worker pattern. Now, which actually is an older pattern because that was applied for workflows, right? But in the AI world, this is a new pattern, right? And this is what, if you look at what Anthropic says in this is something that we recommend because you can now provide the worker the right set of scope to work on, rather than giving it an autonomous or unbounded scope to work on. And it comes back in a much more, deterministic way than an agent, right? So those are some things that, to answer your question, orchestrator worker pattern in an AI world is new. Yeah.
Any other questions? If not, I just want to plug a couple. Oh. I think she was just cheering.
Okay.
Yeah. And to learn more about that, in about, half an hour maybe now, we're going to have a really great session with Purnima, our GM, Oren, and Deshaun, one of the, again, most well-known Spring advocates. It's right upstairs, 3:30. We're going to talk about many of these same things. And there's a couple more around how to, again, get your dev and operations teams ready for the AI PaaS and platform engineering for the AI-driven enterprise for those that are more on the platform SRE ops side. So thanks for coming to the session. Thanks for supporting Explore, and happy to chat with you guys afterward. And Bert, maybe we talk to the gentleman in the back about kind of the Avi question as well. Awesome.
Okay.
Thanks, y'all.
Thank you.
Oh,